Today I'm going to show you how to use Excel to solve a correlation problem. Before we start doing Excel, let's review what you learned in correlation. Pearson's correlation is actually called Pearson's product moment correlation coefficient, and a lot of time we simply call it Pearson's R. And Pearson's R, the formula is XP, the cross product, divided by square root of sum of square of X times sum of square of Y. And the cross product is summation X minus X bar times Y minus Y bar. And the sum of square concept is something you're very familiar with. Sum of square X is summation X minus X bar square, and sum of square Y is simply calculated as summation Y minus Y bar square. So here's the problem. We have 11 students here from 1 to 11, and we have the information on how many classes they have missed throughout the semester and what's their final exam score. And in this particular question, we need to answer two parts. One is correlation appropriate to measure the relationship between the number of missed classes and final exam scores? And B, is there a significant relationship between number of missed classes and final exam score? Only appropriate when the relationship between these two variables is linear. We entered the information in Excel with students' missed classes and final exam score. And to see whether there's a linear relationship, we just have to highlight the data, click Insert tab, go down to the chart, and there's your scatter plot. Choose the first scatter plot. As you can see, the chart's right here. If you draw a straight line, it will fit the data really well. So by visually examine the relationship between number of classes missed and their exam score, and we conclude that a linear relationship exists between these two variables. We can move the chart out of the way by just delete the chart for now. Okay, so that gives us space to calculate the number we need to do. Refresh your memory. Here's the formula, and so according to the formula, you will need to calculate X minus X bar, and you need to calculate Y minus Y bar, and you will need to do a multiplication between these two terms, and you will need to do a square term for X minus X bar and square term for Y minus Y bar. So let's get to work. Labeling each column is a little troublesome, so that's why I did it in advance. Before you calculate X minus X bar, you need to, of course, figure out what X bar is first. Let's go through the process. First, you add the total sum of all the x's, and then you can figure out the mean of your x is using the total divided by 11 because you have 11 students. Now you need to do the same thing with y, and because it's the same thing, the secret of Excel, when you do the same operation, you can just drag and copy. And see, 825 is the total of all the final exam score for the 11 students, and you need to divide it by 11, and that's the same operation as you did previously. So the average final exam score is 75. So calculate x minus x bar. Here is your individual x minus the mean, and when you need to fix the value, you put in a $ in between. So 0 minus 3 is -3. So for the rest, you just do the copy and drag from the first value all the way to the last value. You need to do the same thing for y minus y bar because it's the same operation and the mean is in the same relatively space. So let's see what happens if you just highlight the entire x minus x bar and drag it over to y minus y bar. Okay, see, it automatically shows you y minus y bar. Let's check the accuracy. First is C2 minus C $14. C2 is 90, C $14 is mean of the exam score 75. So that's how you get 15. And the rest of the number is also accurate. Okay, so the third column here, you need to create the XP, x minus x bar, parentheses times parentheses y minus y bar. So basically is this two value, you do a multiplication, and -3 times 15 is -45. Okay, put your cursor in the right place, drag it from the first value all the way to the last value. Okay, and when you sum it up at the end for all these cross product terms, you have created your SP. So that we just label that -205 is your XP. Okay, now you need to create x minus x bar parentheses square. That's gonna be the sum of your square. S minus x bar there, square. 3 square is 9. That's correct, and so put your cursor at the right place, drag to the last value. Okay. For the y minus y bar, the number is right here. Square. 15 square is 225. That's correct. So drag it to the last value. Okay, remember we need to sum it up at the end. You already performed the sum here. So let's drag across. You're going to see the sum. Okay, so right here, this is going to be your sum of square of x. And this is going to be your sum square of y. Okay, so you can actually calculate Pearson's correlation. Its value is 205. It's right here. That's your XP divided by sum of square of x is 38 times sum of square of y, 1164. And remember, you need to take a square root out. So the square root is power 0.5. Okay, so your calculated Pearson's R is -0.975. Such a calculation process is very helpful when you are doing homework at home and you want, if you just do it on your calculator, you can verify every step away all the number of your calculation, make sure you do it correctly. And I guess in most of the exam situation, you're not allowed to have your computer with you, so it's still important for you to be able to calculate Pearson's correlation using your regular calculator. 7.5, let's go through and finish the question. The second part of the question is there a significant relationship between the number of missed classes and final exam score? Is there a significant relationship? So we don't know whether the relationship is positive or negative. So your hypothesis, step number 1, explicitly state the pair of hypotheses. It's going to be a two-tailed test. Row equals 0, row not equals 0. And step number 2, identify the rejection zone. The critical value for Pearson's correlation. Here is a table for critical value of Pearson's correlation. You need to identify what you're looking at, and the question did not specify an alpha level, so we are going to use 0.05 as our default alpha level. And we did a two-tailed test in our hypothesis 1, so we are looking for the two-tail, alpha equal 0.05. And if you're doing a one-tail alpha equal 0.05, you will be looking at different columns. So be very careful with the top 2 rows, tell you it's whether it's a one-tail or two-tail, and what is the alpha level, which column should you be looking at. And also the degree of freedom for Pearson's correlation is n-2. We have 11 students have missed classes and have their final exam grades. So n-2 is going to be 9. So you look down the table, and the highlighted number 0.602 is the critical value of Pearson's correlation. So basically your rejection zone is absolute value of R greater than 0.602. Okay, and continue on. Your step number 3 is calculate the test statistics, and here's your Pearson's R, and your calculated value turned out to be negative 0.975. So the absolute value of negative 0.975 is greater than your rejection zone, right here, 0.602. So you are within the rejection zone. We reject the HO. When you reject the HO, the evidence is strong enough to support a claim that there is significant relationship between number of missed classes and the final exam grade. Thank you for watching. See you next time.